Sir,
Yeah.
could you give a worksheet on just drawing graphs?
Do you want to try the worksheet which I have given to 11thers? Should I send it to you?
Transformation of graphs, that kind.
Yeah.
Okay.
But that will be very heavy actually. That's not required for AP calculus at least.
Oh. It's okay, I still try it. At least I'll get some.
Okay, fine. I'll send it to you today.
Okay.
Can you see the screen?
Yeah.
Okay. So today we are going to talk about further application of integration. Further application of integration. Okay, so first application that we are going to see is again motion along a straight line. And I'm directly going to do questions with you because mostly all the concepts have been covered in the previous chapter of application of integration. So motion along a straight line. Let's talk in terms of questions. So the first question here is, a particle moves along the x-axis. Okay, so there's a particle which moves along x-axis. Okay.
Mm-hmm.
With a velocity given as 6t square minus 18t plus 12.
Mm-hmm.
Question number 1. Find the total distance covered between t equal to 0 to t equal to 4. Find the distance, okay, covered between t
That means you
equal to
just have to
0.
integrate it and apply the limits from 0 to 4.
That is up to you to do. I'm not going to comment there because I've already explained you. Then find the displacement. Find the displacement of the particle from t equal to 0 to 4. Particle from t equal to 0 to 4. Yeah. Tell me what to do in this case.
Distance is mod of displacement. No, distance is like the distance is mod of displacement, right? To find if you have velocity given to you, displacement will be integration and then from 0 to 4. Apply the limits from 0 to 4.
Do it. Tell me the answer. What do you get?
Okay.
Yeah. Get the answer for the total distance first. And after you tell your answer, I'll start discussing.
Okay. Sir, I think displacement is 32 units.
Displacement is 32. That's absolutely correct.
So distance be mod of integral mod velocity. What would be that?
Okay, again, there is a slight element of confusion. So let me again clear it. See, when you plot velocity graph, let's say here, basically we know that it's a parabola whose roots will be at 1 and 2, correct?
Yeah.
So it would be somewhat going like this, right? So this will cut at 1, this will cut at 2, and there will be a point over here, let's say somewhere here, which is 4. Okay?
Okay.
Now, you have to read this graph. When you read this graph, automatically everything would be clear. In this zone, that is from 0 to 1 zone, your velocity is positive.
Yeah.
So when t is between 0 to 1, your velocity is positive. That means the particle will be moving towards the right.
Right. Yeah.
From 1 to 2,
it's negative.
Velocity is negative. That means the
So
particle
it's
will start
left.
moving towards the left. Correct. Now this right is a positive displacement. Left is a negative displacement. Correct.
Yeah.
Similarly, from t equal to 2 to 4,
4.
again v is positive. That means again the particle will be moving to the right. That means again positive displacement. Correct.
Yeah.
When you directly integrate it from 0 to 4,
Oh, you have to
Okay.
integrate from 0 to 1 and then 2 to 4.
yeah, it gives you the displacement because it automatically, this expression automatically takes this as positive, this as negative, and this as positive again.
Right.
Okay. But we cannot use this for distance formula because in distance formula we have to manually make this positive.
Okay.
Correct?
Yeah.
So from 0 to 1, that would work. But from 1 to 2, you would have to integrate negative v dt.
Yeah.
So whatever is your v, you have to take a negative.
Yeah.
Again, from 2 to 4, you have to take v dt. So this manual negative was to make this entire thing as positive.
Yes.
Okay, now do it.
Yeah. So you can't mod it completely and then take integral.
If you mod it, see, what do you want to, yeah, you can mod the entire velocity function, but even mod you have to redefine it, right? We cannot integrate with mod in place.
Correct.
So when you redefine mod, automatically you'll have to put a negative sign, right?
Correct.
So whenever when you're modding it, you're actually making this graph like this, isn't it?
Yeah.
Because everything else is positive.
Yeah.
So from 0 to 1, you will integrate this expression v, whatever is the v expression, this expression. But from 1 to 2, you would integrate negative of this expression. That's what I have already done over here.
Yeah.
So ultimately, you have to put this. So whether you use mod or you don't use mod, you have to actually put this negative sign.
Okay.
Now this negative sign is to make that area positive because we have to deal every displacement traveled as positive. So this is also positive, this is also positive, this is also positive. Since this was already negative, an additional negative sign was required over here.
Correct. Yeah.
Okay, now complete this integration and tell me the result.
Yes.
Adjust this here itself. This is going to be 2. This is going to be 9. Yeah, when you put a 1, what do you get here?
Oh, I was okay. You get
5.
2 minus 2 plus 2. 4, 5. 5.
Yeah.
Then
Here
you
we'll get minus 16 plus 36 minus 24
minus 24
and
minus
5 again.
2 minus 5. Yeah.
Minus
2.
of minus 1.
Yeah.
This will be 4 cubed, that is 64. 64 minus 8 is 56. 9, 16 minus 4 is 12. 2, 2. So that's 5. And here I'll get plus 20 minus 4. That's 1. And this will be 112 minus 108 minus 24. That's 6. Why am I getting negative answer here? 1 will give you minus 5.
So I think it's 5, not minus 5.
This one?
Yeah.
When you put a 1, you get a minus 5, no?
Okay. Yeah.
Okay, so this data was plus 20 minus 4. That's correct. Here when you put a 4, you get a 4 cube. That's 64. 64 minus 8, 56. And 16 minus 4 is 12. And this is going to be 40. Yeah. So 108, 112, 24. Why am I getting a negative answer? Let me check in case I missed out anything. 14 minus 9, that's fine. That's correct. 16, 36. Minus 2 minus 14, that's plus 5. That's 9 actually.
No. No, it's fine.
Minus 4 plus 5, that's 1. Yeah. Why? 4 cube is 64, right?
Yeah.
So 64 minus 8. 64 minus 8 is 56. This is a plus, right? Yeah. Now you got it. So this is 136 minus this, which is going to be 28. So the answer is 34 meters. Okay, fine.
Yes, sir.
Okay, we'll take another one.
Okay.
If a body moves along a straight line with a velocity t cube plus 3t square, Find the distance traveled between t equal to 1 and t equal to 4. Find the distance traveled between t is equal to 1 and t is equal to 4. So first try to see the sign of velocity. In what interval it is positive, in what interval it is negative.
Yeah.
So will this ever be negative, by the way? In this interval 1 to 4, will t cube plus 3t square will ever be negative?
No, it'll always be positive.
Always be positive.
Yeah.
Right? So roughly speaking, if you factorize it like this, okay, it will have a 0 point as at -1, -3, okay.
Yeah.
So it will come like
And
this, okay.
You go up.
It will go up.
You come down at 0, 0,
and again
and
go
it'll
up.
go up again.
That means from 1 to 4,
It'll always be positive.
it will always be positive.
Yeah.
So area under this will automatically give you the distance, not the displacement. Yeah. In fact, displacement and distance would be the same.
The same. Yeah.
So you just have to integrate t cube plus 3t square from 1 to 4. That's it. So c to the power 4 by 4. Okay, so that will be 4 cube 64. And again 4 cube 64.
64 plus 64 minus 1 by 4. No.
Plus 1.
Sorry. Plus.
So 127 plus 1 minus 1 by 4.
Yeah.
Yeah. So I think that will come out to be 507 by 4. Yeah.
Yeah. 126 points.
Yeah. Now we'll move on to the concept of motion along a plane curve. So again, let's take questions because most of the concepts you have already taken up in physics also. So I'll ask you some questions.
Okay.
The first question is related to projectile motion. Okay.
Yeah.
Suppose the projectile is launched from the origin at an angle of elevation alpha. There is a projectile which is launched from the origin at an angle of elevation alpha. Okay.
Mm.
And initial velocity is v naught. Okay.
Yeah.
Now, find the parametric equation of its flight path. Find the parametric equation of its flight path, where time is a parameter.
That means find the parametric equation of his trajectory, right?
Trajectory, yeah, with time as a parameter. Okay, so I think it's almost a physics question. So, what is the relation of x displacement with respect to time and y displacement with respect to time?
Yeah. So, but what's running in my mind was only physics, but
Yeah, you can apply physics here.
like,
So x,
okay.
how much will be the displacement of the body along the x-axis in after time t?
Yeah.
What will be the answer?
1 second. Sir, could you just give me a minute? My pen stopped working. Just a
Oh yeah,
minute.
sure.
Displacement will just be V naught T.
Wrong.
Oh, V naught cos.
What about displacement along y-axis?
Yeah.
So this v naught cos alpha would be the one which is responsible for taking it along the x-axis,
Mm-hmm.
and v naught
And
sin
V naught sin
alpha is the
alpha.
one which is taking it up.
Right.
But remember, at the same time, gravity
Is acting, yeah.
g is acting down.
Yeah. So it's V naught sin alpha T minus GT square.
V naught sin alpha t
Minus GT square.
minus half
Half GT square, yeah.
Okay.
Yeah.
Now, if I ask you get a Cartesian equation of its path, you can eliminate your t. So t you can write it as x by v naught cos alpha and substitute it in y. So y will be v naught sin alpha. T will be x by v naught cos alpha. minus half g
Square.
t square. V0 gone. So y will be x tan alpha minus half g x square by v0 square cos square alpha. Now this path is definitely a parabola opening downwards because the coefficient of x square is negative. Okay, so hence it would be tracing a path like this.
Okay.
Okay.
Yeah.
Now from
So
this,
parametric equation just ends in the previous step, right?
yeah, this is the parametric equation where you write x as a function of time and y as a function of time. That's it.
Okay.
Okay. Next question. A particle moves along a curve in such a way that dx by dt, that is its velocity along the x-axis, is always related to its coordinate. Let's say x comma y is the coordinate of the body at a given instant of time. Then dx by dt is 2 root x, and dy by dt is 1 by x. Okay. It's given that at t equal to 0, the particle is at 1 comma 0. The particle is at 1 comma 0. Find the Cartesian equation of the path of the particle. Find the Cartesian equation of the path of the particle. If you have any idea, then you can try. If you have no idea, then you can just think for 1 minute and then I'll start helping you out.
No, I will try.
Okay. Any idea, Shreya?
I thought that we should integrate dx by dt and dy by dt but with respect to t.
With respect to t. But how do
Yeah.
you integrate this with respect to t?
So that's what I thought. So basically, since you said at t equal to 0, particle is at 0 comma 1, that means the relation between t and x should be x equal to t plus 1, which is I don't think is right. But
No. Just there can be so many relations. Okay, now see how it works. First of all, focus on this term. Dx by dt is equal to 2 root x. Now, we will integrate, but by a method which we call as separating the variables out. So you brought this dx, brought this root x along with dx like this. Dt you kept it separate.
okay.
Now you can integrate. So what are the integration of this term, that is x to the power minus half term? This of course will be 2t plus a c. Now what are the integration of this?
It will be
Correct.
1 by Yeah.
Now, how do I get a c? Now use the fact that when t is 0, this is your x value, right? X is 1.
So your C is 1.
No, c is 2.
Okay.
Correct?
Yeah.
So I put x as 1, I put t as 0, and I got the value of c as 2.
Yeah.
That means root x is equal to t plus 1. Agreed?
Yeah.
So this is how your x coordinate is related to time. So when t is 0, x will automatically become 1.
Right.
Okay. Next
Yeah.
is dy by dt is 1 by x. Now there are three variables here. Y, t, x.
Hmm.
Correct?
Yeah.
So how will I deal with this? It's very simple. Since we have already found x as t plus 1, I can write this term as dy by dt is 1 by t plus 1 the whole square. Because
Right.
from here I can say x is t plus 1 the whole square.
Yeah.
Correct?
Yeah.
Now I'll give it the same treatment which I gave to x. I will write this as dy by dt is equal to 1 by t plus 1 the whole square. I will send this dt on
Take
top.
dt to the other side. Yeah.
And then since the variables have been separated out, we'll integrate both sides.
Hmm.
So this will become y. The integration of this will be minus 1 by t
Yeah. Plus C.
plus a c.
Yeah.
Now how do I get this c? By using the fact that when t is 0, y is also 0.
Yeah.
So what's c then?
C is 1.
1. Correct?
Yeah.
That means my y is nothing but minus 1 by t plus 1 plus 1. Correct? If you want, you can
Right.
simplify this. It will be minus 1 plus t plus 1. That's going to be y is equal to t by t plus 1. Now y is t by t plus 1, x is t plus 1 the whole square. Correct?
Yeah.
Now I have to eliminate t between them to get the Cartesian form. This is right now in the parametric form.
Yeah.
Correct? So what I can do is, from this relation I can say t is root x minus 1.
Right.
Okay. Of course, I cannot take minus root x minus 1 because in that case t would become negative,
Which is
right?
not
Which is not possible. Time cannot be negative.
Yeah.
So now I put this as t over here. So your Cartesian equation will be y is equal to root x minus
X
1.
minus 1 by root x.
Okay. And if you want, you can square both the sides and try to simplify it again. So this becomes your final answer.
Okay. Okay.
Right? So the idea is do not start the integration till you have separated the variables out.
Right.
Next question. A particle is again following the same curve as what we just now did. A particle is following this, okay? And of course, when t is 0, the particle is at 1, 0. Okay? Now, there's an additional question to this. If this particle is in motion from t equal to 0, if this particle is in motion from t equal to 0 to 1, then find its position, number 1. Second, find its velocity. Third, find its speed. Fourth, find its acceleration. find its distance traveled. Okay. Now all these first four have to be found at t equal to 1, and the last has to be found out for the final. That means in the interval 0 to 1, how much distance it has traveled. Okay. Do this.
So can I use the equation from the previous question? Should I solve it all over again?
Of course, you have to use that actually.
Okay.
So x was actually,
Position.
I'll again repeat it. X was actually t plus 1 whole square. And y
Yeah, and y is equal to t by t plus 1.
You can use this.
Okay. So position is 1, 0.5.
Position is, they say 4, 0.5.
Oh, 2, gosh, I got it wrong. Yeah, 4, 0.5. Yeah.
What about the velocity? It will be a vector quantity, so you state both its I and j components within that bracket.
Okay. Sir, 4, 1 by 4.
Absolutely correct. 4, 1 by 4. So basically, we have to find out dx by dt and dy by dt and put the value of t as 1 there.
Yeah.
So this will be 2 t plus 1. And this would be t plus 1 into derivative of t is 1 minus t by t plus 1
the whole square.
And the moment you put a t, this will become 4. This will become 1 by 2 square, which is 1/4. Velocity is on speed. What would be speed?
So mod of velocity is speed.
Yes.
So x and y will always be a positive quantity if you look at it. So shouldn't velocity and speed be the same?
Velocity is a vector. Speed is its magnitude.
Yeah. So okay.
See, had we waited for Mr. Aditya,
Aditya.
we would have again wasted another class.
Yeah, I mean it's already 9:40 and he's not said anything.
Has it ever happened in Bangalore that you can reach a place dot at a particular time unless until you start early?
Yeah. So speed will be root of x square plus y square, right?
Yeah. So what will be that?
So I got the answer as root of 257 by 4.
How much is it by using a calculator?
Okay.
It will come out to be very close to 4 actually. 008 something.
$4.007, yeah.
Okay.
Yeah.
Fourth part of the question. Find the acceleration. Done?
So 1 second. So 2 comma minus 1 by 4.
Absolutely correct. Yeah. So acceleration would be nothing but double derivative of x with respect to t, double derivative of y with respect to t. Correct? So the double derivative of this term will be 2 itself.
Yeah.
And here it will be minus 2 by t plus 1 whole cube. And when you put t as 1 over here, you get 2 comma minus 1 by 4. Now the last part is the total distance covered. This would be interesting. Let's see whether you're able to do it. Performance pressure. Any idea?
So doing 1 second. Sir, is x equal to 4? Oh, sorry, the distance equal to 4.
No, it's 3.057 units. So basically, it's a motion along a plane. So you have to use the arc length for it. Okay. So remember arc length formula? S is equal to, not S is not speed, it's the arc length, under root of dx by dt square dy by dt square dt integration from t equal to 0 till t equal to 1.
Yeah.
Okay.
Oh, okay.
So dx by dt, what is the expression for dx by dt? I think we have found it a little while ago. 2 times
dx by dt is 2 times t plus 1.
Yeah, 2 times t plus 1 square.
T1 square.
Okay. And dy by dt is 1 by t plus 1 square. Okay, whole square dt, correct? Now, we cannot integrate this by using our methods of integration. So we have to feed this in our calculators.
Okay.
Yeah. So I'll just show you on.
Is this there in the graphing calculator?
Yeah. Most calculators can do integration.
Oh.
Yeah. So it was bracket 2 times x plus 1 square plus 1 upon x plus 1 square. I think instead of square, I can put a power of 4, I guess, right? The same thing, right?
Yeah.
And whole raised to the power of 0.5. From t equal to 1. Submit. It's computing visual representation of the integral. Did we write something else? 2.2. How is it 2.2 now? So, oh, that's 4. That's 4. That's 4. This is 4 over here. Yeah, 3.057.
Yeah.
Cool?
Yeah.
Okay, so you have to be very careful where you have to use your arc length.
Okay. Yeah.
Let's do one more problem.
So on Desmos, they have this cool, like a moving representation of polar curves, like all that.
Ah.
I never realized.
Yeah, they have it.
Yeah.
a particle moves along a curve so that its acceleration is given by minus 4 cos 2t minus 2 sin t. So this is the acceleration of the particle which is moving along a curve. Okay. And your t varies between minus pi by 2 to pi by 2. Okay.
Yeah.
At t equal to 0, the position of the particle is 1 comma 0 with dx by dt as 0 and dy by dt as 2. Question number 1. Find the position vector at any point t. Find the position vector at any time t. That means you have to find your this vector x, y.
Oh.
Note that these conditions are given at t equal to 0, so don't start using it in general. At this moment, your dx by dt is 0.
Okay.
And dy by dt is 2. And the particle is at 1 comma 0. Not in general.
Okay.
Because many people will make the mistake, oh, dx by dt is 0, that means x is a constant, right?
Mm-hmm.
So that's a mistake. Because it is at this position that dx by dt is 0, not always.
Okay. So how do you integrate d square y by dt square or d square x by dt square?
Same way. See. So yeah, I understand what you are talking about. You mean to say that this is given to you as minus 4 cos 2t, correct?
Yeah.
So when you integrate it, this fellow becomes dx by dt.
Oh, like that. Okay, fine. Got it.
And what will happen to this? It will become minus 4 sin 2t by 2 plus a c.
Yeah.
Now to get this c only, this
it is
condition,
substitute
this
t with
condition
0
is
and dx by dt with 0.
correct. So this is 0. This will also be 0. So c will
So
also
c
be
is
0.
0.
Yeah. So once you know dx by dt is negative 2 sine 2t. Again, take this dt on top over here. Okay. Integrate. So this will become x is equal
to 2 cos 2t by 2, which is cos 2t.
Plus again a c.
Plus c.
Now how do I get this c value? You know that
so
at t equal to 0, x is 1.
X is equal 1. So 1 is equal to c. C is equal to 1.
t is 0, cos 2t will be 1, na?
Oh yeah. Okay.
Correct.
Yeah.
Next.
I'll solve for y.
Yeah, solve for y. So I have already given half the answer. This will be cos 2t. You have to tell me this part. d2y by dt square is given.
Yeah. Sir, y is 2 sine t.
Y is 2 sine t, correct. Okay, so this is 2 when t is 0, so c is 0.
2. Yeah.
This implies c is 0. So y will be integration of 2 cos t dt. That's going to be 2 sine t. Again a c. And I know when y is 0, t is also 0. So c is again 0 over here. So y is equal to 2 sine t. So yes, this is the position vector of the particle. The position vector is cos 2t, comma 2 sine t. Okay. Next part of the question is find the Cartesian equation of the path and identify the conic on which P moves. Find the Cartesian equation for the path. Cartesian equation for the path and identify the conic on which the particle moves. So from these two equations, you have to eliminate
T.
Done?
No, how will you? One is 2t, one is t. 1 second.
Now from here we can get
Exactly. Yeah.
sine t as y by 2. Substitute it over here. So x is equal to 1 minus. Okay.
Y.
So y square is 1 minus 2x. Sorry, 2 minus 2x. That's a parabola.
Y square. Yeah.
Can you sketch it?
Mm.
Can you sketch this parabola?
Okay. Yeah, I think I got it. Yeah.
Yeah?
Yeah.
All right. So we'll stop here. We have other applications as well to discuss, which is the Riemann sum application. and definite integral of a rate.
Okay.
Definite integral by use of fundamental theorem of calculus. We have many applications, so we'll take that up.
Okay.
So tomorrow we can have a class.
Okay.
What
So
time
we
is
are
it?
yet to do improper integrals.
Oh yeah. We'll do that. Slipped out of my mind. Improper integrals. We'll do that. Tomorrow, what time do you want the class?
Tomorrow is election day. We can't have any.
Online.
No, I said in the morning. But yeah, okay, yeah, online. But
You're going to vote.
no, I'm saying for you. You won't, because evening. I don't know. So we check with Aditya also.
I'm fine with 12 to 1 p.m. I'll check with him. Okay.
Yeah. Okay. Fine. That's fine. But yeah.
Okay then. Over and out.
Okay.
Bye bye.
Yeah. Bye.